This is the part 2 video of solving equations with radicals and rational exponents. So at any time, if you need to pause this video, pause it. Once I get to the second example, pause it, try to work it out for yourself, and then play it to see how you did. Same with the third example. Give it a try before just watching it and not taking any notes. So we want to solve each equation. These are a little more difficult than the part 1 videos. So looking at this, we have the square root of 4 minus x equal to x minus 2. So if you look at it, there's no way we can just get a number by itself like we were doing the radicals by itself. So let's go ahead and square it. So when I square it, I have to make sure I square both sides. Well, what happens is on this left side, the radicals cancel out. I'm left with 4 minus x. But on the right side, I have x minus 2 squared. Remember, that is x minus 2 times x minus 2. I like to use the area model to multiply binomials. Some of you like to FOIL. That's fine, cool, FOIL, it doesn't matter. You get the same results. So x times x is x squared. X times a negative 2 is negative 2x. Again, negative 2x. And negative 2 times a negative 2 is a positive 4. So when we do this, we get 4 minus x equals x squared. I combine negative 2x and negative 2x. I get a negative 4x plus 4. From here, we need to get everything to one side and get it set equal to 0, which means I'm going to move this 4 to the other side. I am going to move this x to the other side. So I can put it under its like terms like this. These cancel out. I get 0. Yay, that's what we wanted. Over here, I have x squared minus 3x, because negative 4 plus 1 is negative 3, and the 4's cancel each other out. Now I have an x squared, so I need to factor it. Sometimes you have to factor with the x in the box or however you else factor. Sometimes it's just as simple as a GCF. Looking at this one, I notice they both have x's in common, so my GCF is x. I'm going to factor out an x. So I have x times what gives me x squared? That is x. X times what gives me a negative 3x, which is negative 3. Again, it's set equal to 0. From here, I set each factor equal to 0. X is a factor. It is part of it. So I have x equal to 0. X minus 3 equal to 0. Well, look, that's already solved for. Here, I add 3 to both sides. I get x equals 3. Now, the most important part, you have to check for those extraneous solutions. Not only do I have to do it once, I have to do it twice because I got 2 answers for this question. So I'm going to plug in 0 for x, and then I'm going to do it a second time where I plug in 3 for x. You can only use one number at a time. So this is me checking for x equals 0. I have the square root of 4 minus 0 equal to 0 minus 2. 4 minus 0 is 4. 0 minus 2 is negative 2. Square root of 4 is 2. And then we have negative 2. Does 2 equal negative 2? No, which means, oh no, we have our first extraneous solution. That doesn't work. It's not an answer. Now, we check when x equals 3. Okay, so when I check with x equals 3, again, I plug it in for every x. 4 minus 3 equals 3 minus 2. 4 minus 3 is 1. 3 minus 2 is 1. Square root of 1 is 1. And 1 equals 1. Yay, it does work. That one didn't, which means our only answer out of the 2 that we got is 3. Ta-da, done. Moving on to the next one. If you want to pause it to try to work it out for yourself, please pause it, work it out for yourself, and then come back and check in to see if you got it right. So I'm going to go ahead and solve it. Hopefully you paused it and now you're tuning back in. Looking at this, I have a big mess. What I want to do is right now I see that this right here is a negative radical. I'm just going to move it to the other side to make that whole radical positive. When I do that, I add 1 minus the square root of 1 minus x to both sides. Okay, so those cancel out. I'm left with x plus 5 equals the square root of 1 minus x. Perfect. Now we do like we did the first example. That makes complete sense. The first example of this video. So I'm going to go ahead and square both sides. Again, you can foil or area model this one. So I'm going to go ahead over here. I like the area model. Remember, x plus 5 squared is x plus 5 times x plus 5, which we get x squared, 5x, 25. So it multiplies out to x squared plus 10x plus 25. You could even use a binomial theorem, that Pascal's triangle, if you wanted to. It doesn't matter. On this side, again, the radical cancels out the exponent. I'm left with 1 minus x. I move everything over. So I subtract 1 from its like term. I add x to its like term. I get x squared plus 11x plus 24. And it equals 0. Now that it's here, it's not just a GCF. There is no GCF that goes into x squared, 11x, and 24. So I actually have to factor. I don't care how you factor. Just factor and check your work with me. I factor a different way than most people. I'm okay with that. You find what works best for you. So, me factoring with the x in the box. I'm going to do it super duper quick. You multiply the first times the last. That goes on the top. You put that middle term on the bottom and you think to yourself, what can we multiply to get 24 and add to get 11? Oh, yes, 8x and 3x. When I add 8 plus 3, I get 11. When I multiply 8 times 3, I get 24. Perfectly. We add the x's there because there's x's here. X times x is x squared, and when I'm adding x's, I have an x. Okay, we go to the box. First term, first square. Last term, last square. The two empty terms, that gives us our middle one. We just found those numbers right here. The x is only meant to organize your thoughts. It's a form of organization. Now, I go to the box. What does x squared and 8x have in common? They both have an x. That's it. Then I think to myself, x times what gives me x squared? That's another x. X times what gives me 8x? That's a positive 8. And x times what gives me a 3x? It's a positive 3. And if I check, 8 times 3 is 24. Perfect. So I write out my factors, x plus 3 times x plus 8. It does not matter if you write x plus 8 first. Guess what? It's the same thing. That's why we have the commutative property of multiplication. Now that I have this, I set each factor equal to 0, and I solve. So here I need to subtract 3 from both sides. I get x equals a negative 3. Here I subtract 8 from both sides. I get x equals a negative 8. But I am not done. Why? Because I need to check my answers. One of these could be that extraneous solution, that extra solution, that fake solution. However you want to talk about it. But we have to check. So I'm going to start with checking x equals a negative 3 by plugging it in. Again, go to your original equation just in case you made a mistake throughout the work. I have a negative square root of 1 minus a negative 3. Be careful because it is minus, but we're plugging in a negative number, plus a negative 3 plus 5, and we hope that it equals 0. So 1 minus a negative 3, two negatives make a positive. 1 plus 3 is 4. That turns into minus 3 plus 5 equals 0. The square root of 4 is 2, so it becomes negative 2 because of the negative right here. Negative 3 plus 5 is 2, and negative 2 plus 2 is 0. 0 equals 0. Perfect. That is an answer right there. Okay, now you can't be lazy. You still got to check that second one. Okay, that -8. It could work, it could not work. We don't know. So now we're plugging that in. We have 1 minus a -8 under the square root plus a -8 plus 5. And we hope that it equals 0. We hope. We never know. So 1 or 2 negatives again make a positive. 1 plus 8 is 9. -8 plus 5, that gives me a -3. The square root of 9 is 3, and because it's negative on the outside, we have that negative. And -3 minus 3, unfortunately, it's not 0, it's -6. This does not work. So x equals -8 is not an answer. We only have one answer for this one. Okay, now our next one's going to be super challenging but super fun at the same time. So here we go. We have this fun mess of stuff. The square root of a -5x minus 4 equal to the square root of a -x minus 4 plus 4. Now, there is no way I can go without no way I can go with getting rid of a radical or just getting a number to one side. So we have no option but to just square it how it is. That's all we can do. So here we go. I am going to square both sides, but I have to be careful because this left side, yes, the radical does cancel out, and I'm left with a -5x minus 4. But on the right side, I cannot just cancel out the radical. I actually have to multiply it out. So I'm going to use the area model. So our first term is going to be the square root of -x minus 4. And then the second term is 4. Again, the square root of a -x minus 4 plus 4. This 4 didn't show up. There we go. Here we go. The square root of -x minus 4 times the square root of -x minus 4 is just a -x minus 4. The square root of -x minus 4 times 4 is 4 times the square root of -x minus 4. Okay, again, we have 4 times the square root of -x minus 4, which is just 4 square root of -x minus 4, and 4 times 4, 16. So when we do this and combine our like terms, we get a -x minus, I'm going to add this -4 and 16. That gives me a positive 12 plus 4 rad -x minus 4. Now, this 4 right here cannot be combined with the 12 because that 4 is attached to the radical. Leave it alone. So I'm going to substitute this back in. -x plus 12 plus 4 rad -x minus 4. Now, I want to move this x over. I want to move this 12 over. So when I do that, I get -4 x, and I get -16. And it equals, oh, I didn't add right. No one stopped me. No one's here to stop me. So correction, stop, look. 4 plus 4, that is an 8. So I need to fix that right here. This should be an 8. Again, I messed up. I did not combine my like terms. So my like terms right here, 8. 4 plus 4 is 8. Square root of -x minus 4. Okay, so these cancel out here. I'm left with 8 square root of -x minus 4. Now, typically we want to get rid of the 8. We want to get that radical by itself. But for this one, if I divide both sides by 8, I have -4 divided by 8, and I really just don't want to deal with fractions. So I'm going to leave the 8 where it is. You could divide by 8, but again, just to avoid fractions, I'm going to leave it how it is. Now from here, We need to get rid of that radical. We really, really need to get rid of that radical. So we're going to have to square it again. Square it again. So I'm going to square both sides again. Yes, I know, it's a lot of work. So remember, negative 4x minus 16 squared is negative 4x minus 16 times negative 4x minus 16. Use the area model. Do it. FOIL. I don't care. Just do it. I'm going to go ahead and just say what it is for the sake of the length of the video. So we get 16x squared plus 128x plus 256. On the other side, what we are doing is we're doing 8 times the square root of negative x minus 4 times 8 square root of negative x minus 4. Well, 8 times 8 is 64. The square root of negative x minus 4 times the square root of negative x minus 4 is just negative x minus 4. You have to make sure you distribute that 64 to both terms because it is being multiplied. Remember, that was the 8 on the outside being multiplied. It became 64, so now you have to distribute. When you distribute, okay, you get negative 64x minus 256. So that's what goes here, negative 64x minus 256. From here, we want to get everything to one side so we can factor and be done with this. So we add 64x, we add 256 to both sides. Again, only with its like terms. Over here, they cancel out. They give us that beautiful 0 we wanted. On this side, we have 16x squared. 128x plus 64 is a positive 192x. And 256 plus 256 is 512. Okay, again, these are some big numbers, so let's look for a GCF. What number are all three terms divisible by? 16. That makes our life so much easier. Okay, so we have 16 on the outside, which gives us x squared plus 12x plus 32, and it's equal to 0. Now we factor that inside part. So factor it using the x in the box. First times the last, so 32x squared, 12x on bottom. What can we multiply to get 32? Add to get 12x. That would be an 8x and a 4x. First term, first square. Last term, last square. 8x plus 4x gives me that 12x. 8x and 12, slow down. X squared times, or x squared and 8x, I'll get it right eventually, have an x in common. X times x gives me x squared. X times 8 give me 8x, and x times a positive 4 give me 4x. So my factors are x plus 8 times x plus 4. Does not matter the order you write them in, equals 0. Don't forget we have that 16. We set each factor equal to 16. Or equal to 16. Equal to 0. I'm sorry, I'm messing up. This problem's just been so long. So 16 equal to 0, that's a number equal to a number that's not true. So we don't worry about it. If it's a variable, then it is important. But since it's just a number, 16 does not equal 0. It's not a valid statement, so we just cross it out. Okay, we get x plus 8 equals 0. We get x plus 4 equals 0. We subtract 8 from both sides. We get x equals a negative 8. We subtract 4 from both sides. We get x equals a negative 4. But wait, there is more. Why? Because we have to check for extraneous solutions. It would suck to do all this work and not get the correct answer. I just noticed I forgot a negative sign right here. So let me fix that so you can see it better. Negative 8. So we have to check for both of our numbers. Both of our numbers. So here we go. I'm going to start with negative 8. We're checking our work. I'm plugging negative 8 into both equations. both sides. So negative 5 times negative 8 minus 4. And then we have equal to the square root of a negative 8 minus 4 plus 4. So here we go. Negative 5 times negative 8 is a positive 40 minus 4. That gives me a positive 36. And the square root of 36 is positive 6. Let's check the other side, see if it equals that. Two negatives make a positive, which gives me a positive 8 minus 4 plus 4 here. 8 minus 4 is 4 plus 4. Square root of 4 is 2 plus 4, which gives me 6, and 6 equals 6. So yes, that answer works. Now you can't be lazy and just assume negative 4 doesn't work because that's how it's always been. You never know when it's going to switch it up on you. Okay, so check. Don't be lazy. We have the square root. We're checking x equals negative 4 now. We have the square root of a negative 5 times a negative 4 minus 4. Over here, we have the square root of a negative 4 minus 4 plus 4. So negative 5 times 4 is 20. 20 minus 4 is 16. Square root of 16 is 4. Negative 4, two negatives make a positive. Minus 4, that's 0. Square root of 0 plus 4. Well, the square root of 0 is 0 plus 4 is 4. 4 equals 4. So we have two answers. They both work on this one. Yes, that was a very long and tedious problem, but we did it. We made it through it. So this is the second video of solving equations with radicals and rational exponents. If you need to go through and rework the examples again on your own and check your answers, do it. You need to know the process. That is the most important part.